All right, hi today guys. We're going to walk through lesson 7. Lesson 7, a nice easy one. We're going to compare relationships with tables. And what we want to be able to do after today is to decide if a relationship in a table is proportional or not. And we'll start out with this, this warm-up. So we're in lesson 7 in your books. Our lemonade recipe calls for 5 cups of juice of 5 lemons, 2 cups of water, and 2 tablespoons of honey. And it says invent 4 new versions of this recipe. One that would make more lemonade but the same taste, one that would make less lemonade but the same taste, and one that would have a stronger lemon taste. Doesn't matter what size, it doesn't tell us, as long as it's stronger lemon taste than the first one, and one that would have a weaker lemon taste than the original one. Okay, so I'm going to let you fill that, or I made a table. I'll let you answer that question. It's a good one. Now, on the next page, this is our big takeaway here, and this is the one I want to walk through you with. It says entrance to a state park costs $6 per vehicle. So every time there's a car, that costs $6. Plus there's they're going to charge $2 per person that's in the vehicle. So if we have 2 people in the car, that would cost us $6 for the car plus $2 for each of those 2 people, which would be $4 plus 6 would be $10. If we have a car with 4 people in it, it's still going to cost $6 for that car plus 4 times the $2. That would be 8 plus 6 would be $14. So how much would it cost for a car with 10 people in it? Or maybe this is a bus or a van. Still costs $6 for that vehicle, plus now we have 10 people, $2 each for them, so that would be 20 plus 6 would be $26 for all 10 people to go. Now it says, question number 2, for each row in the table, if each person in the vehicle splits the entrance cost equally, how much will each person pay? Well, let's see. I've got $10 divided by 2 people. Each person would pay $5. $14 divided by 4 people, each person would pay, I believe that's $3.50. If I have $26 paid among 10 people and I divide that evenly, that's $2.60 each. So the more people you have in your party, the less money each person has to pay. Next question, how might you determine the entrance cost for a bus with 50 people? So that bus, still the same, it's still a vehicle, it's still going to cost that $6. So you guys figure out how much it's going to cost for 50 people. And then the question, the big one for us here. So do that math out, hit pause for a second, find out what that cost is for the 50 people. And then the big question here is the relationship between the number of people and the total entrance cost a proportional relationship? Well, remember what that means. It means that there's the same number. I go from here to here by multiplying by the same number. Well, to go from here to here, when I divided, I did not get the same number each time, so we say, no, it's not proportional. And the reason I know that is because when I divided, I did not get the same number each time. So this is the first time this year really that we've dealt with something that's not a proportional relationship. Every other relationship we've looked at has been we multiply by this to get to this. That's not the case here. What we notice and what we know about proportional relationships is there is a constant of proportionality. We're multiplying by the same thing each time. That's not true here, so it's not a proportional relationship. And really, again, that's our big takeaway from this lesson, is that idea of proportional relationships. So the question here is, Han and Claire were running laps around the track. They coach recorded their times. We want to know how many minutes per lap. So you're going to divide each one of those. Divide those out and record their minutes per lap. Divide, 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 record those minutes per lap. And then the question is Han running at a constant pace? Is Claire running at a constant pace? And how do you know? So taking a look at those, is there a constant of proportionality between each section? Okay, so divide those out with your calculator and figure out, is either one of them running at a constant pace? So for our practice problems today, I want you to do number 1, decide whether each table could represent a proportional relationship. And again, we find that by dividing. Do we get a constant number or not? If the relationship is proportional, what would the constant of proportionality be? Okay, so if we divide and we always get the same number, that's our constant of proportionality. I want to work together with you on number 2 here. This one's a little bit confusing, okay? And then I'll have you finish up for homework. So the difficulty here with this problem is just the wording more than the math. It says a taxi service charges $1 for the first tenth of a mile, and then after that, a tenth or 10 cents for each additional tenth of a mile that the taxi is driving. Fill in the table with the missing information, then determine if this relationship represents a proportional relationship. So we're going to find out what's going in that second column, and then we're going to divide each one of them and see if we get the same number each time. So it charges $1 for the first tenth of a mile, and then 10 cents for each additional tenth of a mile after that. So if we're going 9 tenths of a mile, $1 for that first tenth of a mile. So for that first 1/10 of a mile, so we need to think about that. We've taken 1/10 of a mile on this ride, and we've paid for it. So that leaves us with 8 tenths of a mile, 8 of those units that we need to pay for. So 8 of those 10-cent things means an extra 80 cents. So in total, the cost would be $1.80. Sorry, my mask is on here. Now, if we're riding 2 miles, again, we have that first tenth of a mile, which leaves us with, let me think, 2 miles is 20 tenths of a mile. So that's going to leave us with 19 tenths that we still have to pay for. 19 tenths at 10 cents each would be $1.90 plus that $1 that we paid with to begin with. So for a total of $2.90 if we drive 2 miles. For 3 miles and 3 1/10 mile, that first 1/10, or maybe it's that last 1/10 we're going to pay for. So that's $1. And then we have 3 tenths left. Well, 3 tenths is, or 3 miles left is 30 tenths. So we need to pay 30 times that 0.10, that's $3, which is going to leave us a total bill of $4. And then for 10 miles, again, that first tenth of a mile we're going to pay $1 for. 10 miles is 100 tenths of a mile. So if we take off 1/10 of a mile, we're left with 99 tenths of a mile. We're paying for 99 tenths of a mile times 10 cents would be $9.90. So for a total of $10.90 for the entire ride. So now again, what's relevant to this lesson is the more important part. Do we have a proportional relationship? And we're going to find that out by dividing, like we always do. That number that we came up with, so for example, the $1.80, I'm going to divide it by 9 tenths. I'm going to take $2.90 and divide it by 2, and $4 and divide it by 3 1/10. $10.90 dividing it by 10. Do we always get the same number, or do we not? If we do, then yes, it's a proportional relationship. If the answer is no, then it's not. All right, next question. A rabbit and a turtle are in a race. Is the relationship between the distance traveled, is it proportional for either one? If so, write an equation that represents the proportional relationship. So this one is not hard. We're going to take the turtle's run and the rabbit's run and just divide them out. Divide, 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 divide. Do I always get the same number or not? If we do, if we always get that same number and we always do the right divided by the left, the y divided by the x, that gives us our constant of proportionality, which we call k for some reason and not c, I don't know why. But we divide that out. If we always get that same number, that's what happens when we get 1. That's our constant of proportionality. And again, what they want you to do, sorry, I'm in a busy room here. What they want you to do is, if it is a proportional relationship, write that equation, y equals whatever that constant of proportionality is times x, okay? If it's not proportional, we don't write it. The next section, for each table, answer what is the constant of proportionality, and again, we find that by dividing y divided by x, b divided by a, the right divided by the left each time. And then we'll finish this last one. Kieran and Maya are standing at the corner of a rectangular field of grass looking at the diagonally opposite corner. So they're standing here, looking over here. Kieran says that if the field were twice as long and twice as wide, then it would be twice as long from here to here. Maya says it would be more than twice as far, since the diagonal is even longer than the side lengths. Do you agree with either of them? All right, so we'll finish those up for homework. We'll see you in Zoom on Wednesday. We're just about finished with what I want to do before Thanksgiving. So we'll just kind of wrap everything up, and we'll start our second quarter on Monday with lesson 8. All right, and have a wonderful rest of your day. Bye, guys.